Okay, so this section is on scatter plots, and we have watched a couple of videos, and now we're going to look at some practice problems before I turn you loose on your own. If you look at problem number 1, first of all, directions say to state if there appears to be a positive correlation, a negative correlation, or no correlation, and if there is a correlation, describe it as linear, quadratic, or exponential. So if you look at problem number 1, as let's say time goes on or as x gets larger, does there appear to be a correlation with the y values? Well, when we get to 20, we're about at 0.5, and then when we get a little bit bigger, let's say 30, we have a couple of answers here. One is about 0.5 and one is about 0.3. And as we continue to increase, notice that the y values are sort of everywhere, right? They're not going up, nor are they necessarily going down as x gets larger. In other words, as we look at this, there appears to be no way to imagine a line that could pass through and sort of give a pattern to these dots. So this would be no correlation for number 1. No correlation. If you look at number 2, I don't know about you, but I can sort of see a pattern here. As x gets larger, it appears to me that the y values are going down, generally speaking. So this would have a negative correlation, and this appears to be linear. If you look at number 3, it appears to me that, generally speaking, as x gets larger, the y values are going up. So I would predict that over time, they continue to probably go up, something like this. So that would be a positive correlation. And I don't know about you, but it looks to me like this is almost a parabola, sort of a quadratic look, because it's possible that over time these may take a turn down, right? We really don't know. So I would say that it appears to be quadratic. And number 4 seems to me that as x gets larger, the y values are going down, and look at how fast they drop. In very little amount of time, they went from this huge number here all the way down to 0 in just a short amount of time. So this appears to have a negative correlation, and I would say it appears to be exponential as well. Okay, so this just proves that when we do a scatter plot, we may not have a linear regression line. We could have a curve of best fit, and it could be a quadratic or an exponential. And we will look at some of those later on in the course. Number 5. Number 5 says to construct a scatter plot and determine if it has a positive correlation, a negative correlation, or no correlation. And again, they want to know if we have a linear situation, a quadratic, or an exponential. And rather than to try to plot all of this, I'm going to just go down and we're going to look at the answers here. And if we take a look at this, we can see that on problem number 5, if we plot these points, let's see how these are plotted. Let's look at this first set of data here. For this point here, we go over 1,000 and then we go up 1,300. So if we go over 1,000 and up 1,300, we would end up plotting this point here. And if you go to say 4,000 up 2,400, you would end up plotting this point here. So that's all they really did, was they just looked at the x values and the y values, and they plotted all of those points. And we can see that this is definitely a positive correlation, and it's almost linear, and that's why they have positive correlation and linear. In fact, this is very linear, I would say that this has an R value that is very close to 1. If you look here, if you plot these points, we can't tell that there's any trend that's positive or negative. We really just can't tell. So this would be no correlation. And no correlation tells me that we would have an R value that is pretty close to 0. And of course, I would have to type all of this data into the calculator to figure out the R value. Okay, so I'm going to pause the video and then we will switch to another set of points.